Hello everyone. So today we will talk about Java virtual threads. As we know, this is a like new features of Java 21. It is a like project Loom we can say. So this virtual threads actually, what is this virtual threads and what is the like how we are going to use this one? What is the benefit of it? How it will improve the performance of this one? So those things we are going to like discuss in this tutorial. So basically, virtual threads are like managed by the JVM, and it's are very lightweight threads that will help us to writing high throughput concurrent applications. Throughput means like how many like units of informations or anything like information or it can process in a given amount of time. That's basically we can say about this throughput. So if we say about this, discuss about this like thread model actually, and so basically we need to think about the what is the platform threads. So as well as also it will be say as a classic threads. Okay. So in Java basically this threads actually instance of java.lang.thread class. So Java has like treated the platform threads as thin wrappers around the operating system threads. Suppose there is a one OS thread and that is actually kind of the wrapper that is called a platform threads. Creating those kind of the platform threads has always been costly due to there are a lot of things basically that can maintain by the operating system. So that's why it's been very costly to create. So Java has been using the thread pool for avoiding the overhead of thread creations. So the number of platform threads also has a limited because these resources are basically depends on the performance of your hardware and the whole machines. Because the platform threads are mapped one to one with the operating system thread. Okay, so this is basically kind of the little bit descriptions of these platform threads. Next, we will talk about that what is the basically we are the means basically whenever we're going to do working with the multiple threads and some kind of thing, then what is the issues basically we are going to face with these platform threads. So platform threads actually always been easy to model, program and debug because they use the platform units of concurrency to represent the application's unit of concurrency, right? So that is basically called this thread per request pattern, but this pattern limited the throughput of the server because the number of the concurrent requests that basically server can handle. So that is basically directly depends on the server hardware performance. So the number of available thread has to be limited based on the like as it is based on the hardware, so it is also like limited in even the multi-core processor system. Also latency also big concern. If we see these things very closely, then microservice in a microservice world basically a request is served by fetching or updating data on multiple system and servers, right? So while the applications wait for the is informations from other servers, the current thread basically remains in an idle state. So this is the like waste of resources and the major hurdle to achieving the high throughput of these applications, right? So for solving this one basically uh, like what there is a another things kind of the like asynchronous kind of thing, or we can say reactive programming. As you know, in case of the reactive programming or asynchronous programming basically it's not wait for the response from other system. The asynchronous API is basically not waiting for the coming response from the other servers, rather they walk through the callback kind of mechanism, right? So whenever any thread basically invokes a async API, the platform thread is return the pool until the response come back from the remote system or database. Later, when the response arrives, the JVM will allocate another thread from the pool that will handle the response and so on. So this way basically multiple thread are handling the single async request. So in this async programming, the latency is removed, but the number of platform thread basically is still limited, right? In a one core or two core CPU, still there is some limitations for generating or creating the platform thread. So we need to limit of the scalability of this like system. And another issues with this React team or async programming is to it's very hard to debug the program, right? Means suppose we are handling lot of things in a multi-threading system, so for because all those threads are means not a dependent with each another, so there is some for debugging and all those things, if any issues is occurring, so those kind of things are very difficult to debug in this async programming. So these are the basically things that basically issues is coming with this one platform threads. Next we'll talked about this difference between this platform threads and virtual thread. Now if we say about this virtual thread, so virtual thread actually it's also an instance of java.lang.thread package that runs its code of and underlying this OS thread, but it the benefit of this one is doesn't block the OS thread for code the entire lifetime. Keeping the OS threads are free. Many virtual can, that means we can run in this same OS thread. Basically there is some kind of sharing kind of things. So that means high number of virtual thread we can create without depending on the number of the platform threads. And these virtual threads are basically managed by the JVM. So here basically we don't need any extra kind of the context switching overrated, because they are all stored in a RAM as normal Java object. So similar to the traditional threads, basically the application's code run in the virtual thread in the interdurations of the request, but the virtual thread also consumes the OS thread only basically when it performs the calculation on the CPU, else it will not block the OS thread. Okay, so this is kind of theoretically about this virtual thread. We'll also see how we are going to create this virtual thread. There are kind of some syntax that we need to follow, but not complex one, and also we'll check what is the difference between this platform thread and the virtual thread. Basically virtual threads are always a daemon thread. Suppose if we, as you know, we can set any thread daemon thread using set daemon, which is basically method of this thread class. So there is basically one boolean flag we need to pass, either true or false. So if we set as a false for this virtual thread, it will not impact the virtual thread, it will not change anything for this one. Similar kind of things, it's always having a normal priority. Virtual thread always having a normal priority, means the priority cannot be also changed. Suppose, as you know, we can also change the priority using the set priority. I'll show you in a real time how it will look like, but as a theoretical I'm just explaining how we can change the priority. But in this virtual thread we are not able to, suppose we have forcefully, if we change the priority set priority, then it will no effect of this one. Virtual threads basically are not member of the active member of this thread groups. When we are going to invoke any virtual thread, if we return the get thread group, if we do, then you return a placeholder thread group name with the virtual threads. Virtual thread also doesn't support stop, suspend or resume method. So these methods basically if we want to do, then this method will throw an unsupported operational exception when we are going to invoke a virtual thread. So these are the some kind of difference we can say between this platform thread and virtual thread. So now if we are going to see the how, I will show you how we are going to create any virtual thread, and how it will be programmatically look like, how easy to create it. And also I will show you if we are creating any platform thread 10,000 platform threads, so how much time it will take. And for virtual thread I will also create the same 10,000, then I will show you the how much time it will take, so that we can differentiate the how much time, so that we can say what is the how the good is that virtual thread, means without it will not block the OS thread, it will perform very easily. It only block when the only some OS related calculation is over there, then only it will block the platform thread. So let's look how we are going to create the thread in a programmatically. So let's check it out, and so that we can show also like what is the like performance wise also, like how which is the better, like virtual thread or like platform thread. So let's check out the code. So here basically for checking like how we are going to create the virtual thread and demonstrating this one, I've created one Java project, and as you know, as a JRE I've used this Java 21 JDK 20. So you guys can download this JDK 21 and then create one project, Java project, and accordingly you can use this Java 21. So here basically we have created one main method, and here I am going to show you like how we are going to create like virtual thread. So for virtual thread, creating for virtual thread, basically there is a 2-3 methods. Basically there is a one option is to, I'm showing you, thread dot new thread dot start virtual thread. And as you can see here, basically as a parameter we need to pass one runnable task. Here basically it will create the virtual thread to execute a task and schedule it to execute. So as you can see, we can start this task something like this. Okay, so like start virtual thread, and then basically for running we need to pass one runnable task. So for that we need to create one runnable, and here basically we need to create one task. So we are going to something like this, and here maybe we can put like sys out. Okay, like runnable thread, READ. Okay, and now this runnable basically we need to pass over here. Okay, so if we run this one, so if you see over here in this here, so this already like using here, it's created this one and already it started, so it's written as also the thread. So what we can do over here for printing this line, maybe we can use this one, and then if we like t dot start, then what it will say, if we start this one, because it's already started, so it will give us some exception like it's already started, right? So instead of that, need to, if we don't need to use this one, now it will not give us the exception, but it should print. So for that either we can use just to check, it should work now. You can see this printing. Okay, so there are other approaches also for creating this thread, like instead of this, like in similar fashion, thread dot start virtual thread, and here basically instead of passing the runnable, we can directly print over here. Okay, and here basically we need to print something whatever we need to print. Okay, so this will also work. There actually basically another approach is there, like thread dot builder. So if we want to explicitly start the thread after creating it, we can use the thread dot of virtual that returns a virtual thread builder, and then accordingly we can start off it. Okay, so for that we are having already runnable class over here, and then we need to use thread dot of virtual. Here you can see two options, either off platform we can also create using this, or of virtual. So we are going to create over the virtual, then we are using the start, and here basically we need to pass this runnable task. Okay, so in this way also it will work. thread t equals to something like this, and then it will basically it will work. Okay, you can see. Okay, so in this way basically it will work. Another approach to create using the thread.builder reference. So how we are going to create this one, let me show you. Thread of virtual dot name. Okay, so here basically we need to provide the name, for example virtual thread. Okay, and next it will return us actually, as you can see, it will return this thread.builder. Okay, so for example it's a t1 thread. So using this we can create another thread also, like maybe this t1 dot start, and here basically we need to pass this runnable tasks. Okay, so this is also another approach for creating this thread. Okay, another approach is to create the thread that is executor thread. So how you are going to do this one, it will create a new thread per tasks, the number of threads basically created by the executor, and in this way basically we can create like something like executor dot new virtual thread per executor. So something like okay, executors dot new virtual thread for executor. Okay, so this is also another option that also you can use. So these 3-4 approaches actually basically is there for creating the virtual thread. So using this is also another approach. So using this approach I will show you like the performance. So let's create one approach for checking the performance of this one. So first of all, we are going to create the platform threads, and then we'll check how we are going to, how it will be performing, for how much time it will take to performing the or maybe you can say like 10,000 tasks basically. So for that we need to write something over here. Okay, so instance instant start equals to instant dot now. Okay, so it will give us the current time. Then instead of in this try block basically we are going to use this executor. Okay, executors dot new fixed full size. Okay, new fixed thread full, and here basically we are going to create the 100 thread full, and then inside of this loop here we will going to create another loop, for loop basically. Why it is taking map? Okay, here basically we need to use I need 0 and then less than. Here basically we are going to iterate 10,000. Okay, and here we need to submit this executor thread, executor dot submit. Okay, and here basically we need to pass the runnable task. So for that we need to create one runnable task. So for that we can use this runnable. Okay, so either this, what we can do, we can simply like sleep the thread for 1 second. Okay, dot sleep for 1 second. So for that duration dot of second 1. Okay, next after that we can print something over here. Okay, something like maybe number of iteration. So here basically what we are going to do, we are going to print the like atomic number. We can take one atomic number for this. So let's take this one, atomic integer. Yes, equals to new. Okay, and this basically atomic number we are going to increase here, dot increment and get, and we can use this final. Okay, and here basically we need to use this final runnable task. Okay, we need to surround it with this. We can print this exception if any exception occurred. Okay, and now basically here we need to print the finish time, like how much time it will take. So for that you can print the sys out time taken. Okay, there is a one duration, actually provide duration between start, already I have defined over here start, and end time is should be like instant dot now. Okay, and we can also provide over here like in millisecond we need, or in millisecond for example. Okay, so this will print the time in millisecond. Let's run this one. It will take some time. So let's wait for some time. As it will take more time, so instead of 10,000 let's try with 5,000. Okay, let's try with 5,000. Okay, let's check. It's still taking time. So once it will done, then after that we will check with virtual thread. So this is a like platform thread, and after that we will use the virtual thread so that we can like differentiate like the time taken for this one. It's almost done. 4,000 is going on. It's done, and it's time taken 50740. It's a millisecond. So that means it will take around 50 seconds, right? So here I'm like 50,000, 50,740. So this time taken, this is a millisecond. Now we are going to use virtual thread. So all the things will be same, only what will be the different, instead of this new fix thread full, we are going to use new virtual thread. Okay, new virtual thread task executor, this one we are going to use. Okay, so let's run this one with the same setup so that we can easily understand. Let's start this one. Let's see, it's time taken 2362 millisecond. So you can see the difference. This time taken for this virtual thread and the time taken for the platform thread basically 50 this millisecond. Okay, so it's basically around 50 to 51 second, and this is a basically 2 to 3 seconds. So you can like understand like what is the difference for processing this kind of amount data, right? So here basically the difference is this and this is the very difference. So we can easily process all the data using the virtual threads very easily, right? This is, you can see, we can easily like print all the data and all those operations. So it's same data we are processing, but in virtual thread it's very easy. So this is basically, you can see like what is the benefit of this virtual thread. So this is basically, this is the benefit. So but there is also some kind of the like best practices for virtual thread if you're going to use. So for virtual thread basically pool is not required, as it is a like Java threadful was designed to avoid the overhead for creating the new OS thread because it was costly operations, but virtual thread are not the expensive one. So for the due to this we don't need to use the virtual thread. So this is the one kind of things, and another thing is for like we need to avoid the like thread local variable, because it's also not required for this one. And another thing is like basically nowadays basically we are using the synchronized block for kind of thread safety, but instead of that we need to use the return lock instead, because there are basically two specific scenarios for that block the platform thread. One is like when it executes a code inside a synchronized block or method, and in a native method basically. So synchronized block does not like make the application syncer, but it will basically limit the scalability of the applications similar to the platform threads. So as a best practice, basically if a method used very frequently and it uses a synchronized block, then consider of the replacing it with the like return mechanism. So these are the kind of like basically limit means the best practices basically we are going to do with this virtual thread. So this is basically about all the things of Java 21 virtual thread. So for summarizing those things, I've explained like what is the virtual thread theoretically, what are the difference between platform thread and virtual thread, what are the different ways of for creating virtual thread, and what is the performance wise, which is the best, and how we're going to implement this one like platform thread and the virtual threads. So that's all for this one virtual thread. If you guys have anything, please do let me know in the comment section. Thanks for watching. Bye bye.